Continuing on to part D of problem 1, we will be looking at this gigantic circuit, which doesn't look at all pleasant. But the first thing I want to point out, before I start approaching this is just my cross-coupled NAND. So basically I can treat X and Y like my A, B. This is a cross-coupled NAND as well. And this is just a slightly modified cross-coupled NAND, which if you've done the Mallard, you should already know how to solve one of these. And I've kind of explicitly written out how this down here will function. So this is A1, A2, and this is B. And so I'm going to solve these things in chunks rather than on the individual gate level because, well, the individual gate level is just going to be a pain in the rear, honestly. And really, at this point, a skill you really need to learn how to use is something called abstraction, where you think of things in like sets of gates as in chunks rather than as individual components. And so I'm going to approach this problem from that perspective. And to help me out a little bit, I've basically put dotted lines every time one of these two inputs to my circuit, the clock and the D, changes. So let's just kind of approach this from a quick perspective. So we're going to assume that initially Q is equal to 1. So we can assume this is the case to start, and we don't necessarily know what Z, Y, W, and X are. But here I'm going to start off with D is equal to 0. So that's equivalent to C equal to 0. And so that means Q bar is going to be 1 anytime C is 0. So that means Z is going to be 1. Up until this point. And we know that clock is 0, and we're going to need to figure out what these are up here. So here we've got clock is also equal to 0, so that means I know that X, so I know Z is 1, so that's going to, let me get my pencil out again. So we're basically putting 1, 0 into my cross-coupled NAND, and so if A is 1, B is 0, this will be 1, sorry, X will be 1, and W will be 0. So we can fill that out really quickly. So X will be 1, and W will be 0. And then now I've got all my inputs to Y. So I've got X, which is 1, clock, which is 0, and I have D, which is 0. So I've got 1, 0, 0. So this should read A1, A2, and B. So A1 and A2 are 1, 0, and B is 0. So Y is also going to be 1. So that's this case right here. And so this is, if this was just a normal operation, this would be one of the prohibitive inputs. But this is a special circuit, so this is not the case. So now, we're changing clock to be 1. So essentially, we've changed this to this, and we've changed this to be 1, and D is still 0. So we know the full functionality of this. So this is 1, 1, 0. 1, 1, 0 is a set. So Y is going to go down to, this is a reset. So this is Y after short delay is going to go down to 0. Z after short delay will go down to, is not going to change. So this will stay the same. And now Z is coming up to here as a 1 still. So we've got the 1 and 1. So that's also still a hold. So X and W should stay the same. So I'm going to do Q last. I'm just going to go through the W, X, and Y, and Z. So now I have clock 0, D 0. So this will switch back. And So what I've got now is I've got this 1, 0, 0. So that's going to keep these two. Y is going to go back up to 1 for this little time period. After a short delay, Z is going to stay 1 for this time period. And since clock is 0, and so we've got this back again, this is just going to stay at 0, 1. Now I've got D is 1 and clock is 0. So this is 1. So now we have the 1, 0, 1 input. So that means Q bar, which is here, is going to change to 0, and Q is going to change to 1. So Y is going to stay the same for a little bit, at least. And we know Z is automatically going to have to change to 0. So Z is going to, after a short delay, will go to 0. And X, which depends on, so this is going to stay, so initially this will stay 1, 0, this will stay at 1, but eventually this will change to 0. So this is changing to 0, and clock is still 0, so we got a 0, 0, which tells us that this is going to enter the forbidden, and so W, after a slightly longer delay, after Z has been affected, will change to 1, X will stay at 1, and so fortunately we see that this 1 and 0 stays the same, so Y is going to stay at 1. Now we've got clock is 1 and D is 1, so we have 1, 1. And so this is essentially hold. So throughout this entire time, Z and Y are not changing. And since, well, this is might change some stuff with X, but we'll have to wait and see. So Z is going to stay at 0. For this entire time. Y is going to stay at 1 for this entire time. And now X and W, how will they change? So they are now receiving a 0 and a 1. So they should be A is 0, B is 1. So X should now become 0, and W should now become, should stay 1. So now that we've got this change in the clock, this will drop down, and this will stay high until here. And now we've got